All right. Hello, everybody. This is Nephew SIG Automation meeting for February 22nd, 2023. Um, Yesterday, we talked about figuring out how to break up into smaller groups that can execute on with a little more autonomy on different areas. So we're still working through how to do that. Please feel free to comment in the agenda document from yesterday. But as part of that, we think we need to uh, talk through the design a little bit more. I know Wim and Stephen and others have been doing a lot of work on the CRDs, but I don't think Wim, that's something quite ready to be talked about today, if I understand correctly. Um,
Yeah, I'm planning to have maybe a dedicated meeting this week still, because we promised to finalize it if we can on that topic.
okay. And then, so what we wanted to do today is we've talked on the last few meetings that Aravind was working on a diagram. So he has prepared that. But as a precursor, I wanted to talk a little bit about some of the primitives he's using in that, which are different than the workshop. So Aravind, do you want to display your screen?
Yeah,
Let
sure.
me, I think I have to give you.
Yeah, no, I just have the sequence diagram. Is that okay, John? You can talk from that.
Sure, yeah.
Okay.
Well, let me make you. Usually, there's a thing on here that says
No,
make.
I think I should be able to present, right? Let me try.
Oh, okay. You don't need to be okay. Well, let me just explain the words. So there's four. You had that doc, I thought, with like the four with the different.
Table,
I mean,
right?
you go from the glossary, but I don't know that I put it all in the glossary yet.
Give me 1 second. So sorry, I think there is some communication gap. Let me see if I can find that.
So basically, I mean, just to give it in contrast to the workshop. So if you've been through the workshop, we had this thing called package deployment resource, and it contained a cluster label selector, and it contained a package reference and labels and annotations, basically. So it would find all the clusters, it would find the repo that's associated with that cluster as its source of workloads. It would clone the upstream package into the repo for that downstream packet for that cluster. And when it did that clone, it would add resources. We call it injection. It would add resources that are specific to the cluster. So the cluster had a resource associated with it called cluster context that gave additional information like a site code and information about what CNI configuration was on that cluster. And it would insert that into the package if the package was asking for it. And that was used then kind of to specialize the package for that given cluster. So just to talk about, define some of the terms here. So when we
Can you see my screen? Sorry,
yes.
John. Can you see my screen?
Yes.
Okay,
Yep.
please.
That's great. So the before Aravind jumps into his sequence diagram, it uses some of these terms. So we thought it might be helpful. It's really tiny. We thought it might be helpful to.
Is this better?
Yeah, that's better. To define these things more clearly for people who haven't necessarily dug into the details. So going down a level. So just like, we're dealing, when we create a workload, we deal in Kubernetes primitives, deployments, and deployments then provision replica sets, which then provision pods. We have a similar structure here where we're dealing with sort of the configuration of the workload or the package that defines the workload before we're gonna actuate it, and we have some primitives we use to deal with those different packages. So the first one is and that API that defines that is our package orchestration or Porch API, and so it's sort of like an underlying lower level API that we're building on top of. And it defines these primitives. One primitive is called a repository, which basically provides the connectivity and authentication information, and can also provide a branch or even a directory that forms the location for reading and writing packages to. A package is just a bundle of resources. Right now in Porch, that's always a kept package, but we are discussing, like, for example, it could be a Helm chart, right? It doesn't have to be a kept package. There's more we can do with a kept package, but that's like a future discussion we can have. But I know it's of interest to some people, so I want to mention it here. So think of a package as like, right now it's a kept package, but it could potentially be a Helm chart or some combination thereof. And so Porch deals in these entities, and they get written and stored and read from a version to store, which is typically Git, but could be OCI. So it's basically just, which is more scalable. It's a version to store. And since it's a version to store, you have something called package revisions. So with the resource that is actually exposed in Kubernetes by Porch is called a package revision. So this corresponds to a tagged commit in that repository, if it's Git, or that has a version number, or it can be a draft revision, which is actually a branch. So there's a life cycle associated with a package that Porch manages. It can go from a draft when it's first created to a proposed revision, and then when you approve that proposal, it's assigned the next incremental version number, and it's pushed into the main branch and tagged. So this is the mechanism underlying our kind of package management piece. So when you go into Porch and you run, if you go through the workshop, you'll run some commands like kept alpha r package list or something like that. It's actually showing you all of the revisions. You may see v1, v2, v3, v4, and then you may see draft. So those are the different revisions. And actually, because it's a Kubernetes-based API, you can actually use kube control. You don't need to use kept to read those and see those.
So John, can I add one thing real quick?
Please.
Just to add to your point, right? On the repository front, one thing that is a little bit subtle is we need to prepare the management cluster before Nephew is ready to do the work for, and the management cluster is ready to do the work for us, right? As part of preparing the management cluster, one of the things we need to do is register the different Git repositories that Porch will interact with prior, right? Like that's one of the steps for preparing the management cluster. And when you register a Git repo or a OCI repo or whatever to Porch, as part of that process, this repository CRD is created by Porch to keep track of the repository that was just registered. That's just something I just wanted to clarify. Yeah.
Yeah, no, that's a good point. And then what the Porch server does is it actually goes into that repository, looks for tags, basically that follow its conventions and things like that. So, and then it presents those as it populates package revision CRs within the Kubernetes API server, which are sort of references to each of those tags or drafts.
Right. Also, sorry, one other point is you could also register an empty repository, right? It's not like there needs to be a package there. At the time of registration, it could be an empty repository, which is the case for all the workload cluster repositories, right? Whichever workload cluster we want Nephew management cluster to manage, we will a priori register those repositories as well. So you will have workload cluster 1 repository, workload cluster 2 repository, for example, and those will be empty repositories. And those will have associated CRs created at the time of preparation of the management cluster. Yeah, sorry, go ahead.
Yes, exactly. That's exactly right. Thank you. Yeah, no, please clarify all you can. Anybody interrupt me and ask questions.
So John, one question, sorry, since we are on this topic. So I understand this at this point from every edge cluster will have its own repo. In my understanding, Porch and config could also deal with individual directories as well within a main repo. For example, if it has to only sync a particular directory, it could do that as well. Is that the right understanding?
Yes, the reason we do so.
Yeah, let me ask the question. So
Yes.
if that's the case, let's say if there are too many edge clusters that we need to deal with, do you think from a scalability perspective, from a purely management perspective, do you think is it good idea to spin off so many Git repos, or do you think
Yeah.
is it maybe an idea to have a less Git repos with directories associated with a edge cluster?
So this is one of the challenges of building on top of Git, and one of the reasons why the tooling also supports OCI. So the way Git works is that you can't pull in Git, the protocol doesn't allow you, as I understand it, to pull an individual directory. You pull an entire repository. So if we say put 1,000 directories in one Git repo for 1,000 edge clusters, every edge cluster would have to pull all 1,000 directories. And so from that point of view, it's not terribly scalable for other reasons. Now, this is a challenge. OCI works much better. OCI is very similar to, it's basically like a container registry, right? So you can do things quite differently in OCI. So we could do that. For simplicity in R1, we've made the assumption or the declaration that one workload cluster, one repository. That's actually going to have to change probably in R2, R4, R3, or R4, some are. And for the reasons you're talking about, it might become challenging or expensive to manage that many repos. And so we might want to do it differently. There's different ways to do that. One is to break the assumption of right now, and this is, maybe I shouldn't go too deep into that, but there's different avenues. Like right now we assume that we're specializing every package for every cluster in the management cluster, but there are times when that's not necessary, and you could use the same package from the management cluster across many workload clusters and specialize on the workload cluster side. But like, it's getting into too deep probably for this conversation. Anne.
Yeah, thanks, John. That answers my. I was not mentioning anything for the R1. That was a general.
Yeah. In general, absolutely. What we need a better strategy right now for R1, just to reduce our scope, we just make this simple assumption.
Yeah, thanks, John.
Yeah. Anne.
Hi. Two questions or points. First, the GitHub repo thing. Right now we are nephew-project, right? That's a folder, really. And then underneath it, there are different repos. We can keep that for R1, right? We're not planning to change that.
Yeah, we're not changing any of that. Here we're just talking about the Git repos that back. So like the package repos that are sort of catalogs read only, the external repos we call them. Those can stay on GitHub, for example. There's no reason to move those around, but the workload clusters are more the ones we're talking about, that when we have to create so many of them. We did in the workshop, we created them in GitHub, and it was hundreds of them, and it was kind of painful. Yep. Now we have Git or Git, I don't know how it's pronounced, in the VM, and so we actually can create local ones, which is much nicer. So like, I think that for our R1 demo purposes, now in a real deployment, maybe you've got GitLab, maybe you've got GitHub, maybe you've got something else. Like eventually those things have to be kind of worked out. But like for our R1 and our testing beds and things like that, I think Git works well.
Second question. Since I don't want to digress and deep dive, but I just want to double check. Somebody had mentioned at one point that they were working on Docker image for these workload. Past R1, we're looking into that. Yes, no?
So we have Docker images for the things that the workloads are using, but they're stuffed in I have probably now out of policy because they've changed the rules. I have a Google TCR repository from like 4 years ago that's JBellAmeric public. And so I just stuffed them in there. That's terrible, right? So the Lucy set us up with a Docker Hub instance where we can push these. But at this point, that Docker Hub instance is still a free tier. It's not an open source sponsored tier. which means it's pretty restrictively limited in number of polls per day and things like that. So we have two choices. One is try to do whatever paperwork Docker needs us to do and see if they'll approve us for basically unlimited account for free, or we create a GCR or the new thing, an artifact registry in our Google Cloud tooling and use that. But that's kind of that's a different question.
Okay, cool. Thanks.
Yeah, thank you. So before I want to try to time box this to another maximum 10 minutes. So while I welcome questions, let's try to keep it a little, I'll try to be, I tend to talk. So I'll try to tighten up because Arvind's got a lot to go through too. And I think this is stuff people have been wanting to hear. So if we scroll back up a little bit, the other thing I wanted to mention about repositories. So we do categorize these repositories into like a catalog, a deployment repository. The only significant difference, like whether it's a catalog, an organization, or external, like a team, we call them team, organization, or external, that's literally just an annotation on there that the UI uses to display it differently. From an underlying API perspective, they're all the same. The only difference is between deployment repositories and blueprint or catalog repositories, meaning deployment ones, the expectation is that the packages in there are ready to be read by the workload cluster and actually applied to a Kubernetes server, whereas the other ones are expected to be used as source material for creating those. So that's hey, you lost our display, Arvind, or at least it went off my screen.
Yeah, it's gone. Yeah.
Okay, so repository just represents our connectivity back to some Git or OCI repo. Porch will surface package revisions, which are tags and/or draft branches of a given package, and Porch will provide you ways to manipulate that. Now, there's another. The package revision is kind of the metadata about it. It doesn't actually contain the underlying contents of the package. There's a separate resource called a package revision resources. It's a plural, and it's for those who are familiar with underlying kind of Kubernetes API technology. It's not a CR. It's served by an aggregated API server. What that means is that when you say get package revision resources, the API server doesn't pull something from etcd and display it. The API server says, oh, that endpoint, I'm going to hand it off to this other server, this aggregated API server, which is the Porch server, and the Porch server is going to serve up that resource. And the Porch server is serving up that resource from a cached version of what's in Git. So those effectively represent directly what's in Git, as opposed to being sort of stored in etcd ahead of time. So you can actually go in side channel and muck with Git. Of course, it's sort of like if you have a database application, going in and mucking with the database, bypassing the application. If you're not careful, you could break expected conventions that the application has. So it's not something you do unless you sort of have to for break glass kind of reasons, but just kind of giving the bigger picture. So we have package revisions. Those are versioned tags. We have each of those is an associated package revision resources, which is basically just a list of all the resources, but not instantiated as Kubernetes objects, just basically as YAML, basically a bunch of YAML. And this is where we'll talk, I don't know if Arvind talks about kept functions or KRM functions at all, but basically they operate on that manifest and make changes to it and rewrite it back to the package. Our controllers do something similar. They read that package revision resource. That's where you insert a IPAM request resource into that list, for example. So those are the very basic resources that we can operate on. And all Porch does is expose these things as Kubernetes resources so we can build Kubernetes style controllers on top of them. That's like the whole point, right? You can use Kubernetes clients and Kubernetes controllers, and you can operate them on the same thing. We can put a watch on package revision so that when a new package revision pops up, we see it, we can do something with it. So building up one layer, those are sort of like pods, right? They're that low level. Then we have something on top that's a little bit more like a replica set or a deployment, something we call package variant. So a package variant describes how to copy, clone, and modify a single package from one repo to another. So if you were doing it in the command line, you'd clone the package with cap, maybe you'd pull it down to your local environment, you'd make some changes to it, and then you'd push it back and you'd tag it and publish it. So package variant, what it does is you give it an upstream package. So that's a reference to a repository and a particular revision of a package. And you say, put that in this downstream repository with this new name. And it's going to be, if there's none there, it's going to be version 1 because, well, it's going to start as a draft. It only actually creates drafts. And it doesn't do it today, but eventually it will also allow you to it'll do the pieces in that. Remember we talked package deployment controller from the very beginning, from the workshop. It does that cloning operation, and it does this injection where it looks up stuff in the workload cluster and adds it to that copy of the package, that clone of the package, that derivative package. Package variant takes that responsibility. So package variant says, aha, you want to clone this. You've defined, it has injection targets. I'm going to go look up those resources. I'm going to inject them in the clone, and I'm going to manage that. So package variant controller, when the package variant resource, which is managed by package variant controller, is going to maintain that relationship. That includes, for example, if you've got 5 different objects you've injected, it's going to put watches on those objects in the cluster. You go and change that object in your management cluster, it's going to propose a new draft with the new object in it. So it takes all of that responsibility for that injection. And there's more that it'll do in the future. It also does things like adoption policy and deletion policy. So if I delete the package variant resource, what happens to the package that's sitting out there in a repo? Do I delete it or do I keep it? Well, there's a policy you can specify when you create the package variant resource that says what you do with it. What if I create a package variant resource and it goes to create the new draft and it sees there's already a draft there? Does it adopt it? What does it do with it? There's an adoption policy around that. So that's kind of captures not just the clone operation, but the injection and the management of the life cycle of the downstream package, and the day 2 type of thing. So when you want to, you've got that upstream package or the downstream package out there running somewhere, and you bump the version of the upstream package, you would go into your package variant resource and you'd bump it to the next version, and it would propose a draft. It would do basically what's a kept package update on the to create a new draft of that, which can then go through the approval process. So that's it manages all of those pieces, and we've sort of teased apart package deployment controller into that and into the targeting or fan out. So I have 3 minutes left. That's where we get to package variant set. So this does the part of the package deployment controller that looked at clusters and then for each cluster cloned a new one. What this does is looks at some target criteria, which could be clusters, could be repos, could be just an explicit list, and it creates package variant resources for each of those targets. That's pretty much all it does. And then of course it maintains them. If the list changes for some reason, it deletes them and all of that. It delegates all of the details of the clone and injection and all that package deployment controller used to do to that package variant controller. So all it does is manage package variant resources. All it does is manage those package variant resources and decide when they should come and go based upon the changes to the criteria, or decide when they should be updated if you, for example, update the upstream that it's pointing to. So that's my overview of the basic primitives that are going to be part of the sequence diagram that Aravind is going to go through. Are there any questions before he jumps in?
I have one question, maybe. Yeah, sorry, you go first. I'll raise my hand. Sorry. Yeah.
Oh, go ahead, man.
No. Yeah, you were first. Sorry.
Oh, quick one then. SMF. Do you see? I guess I should wait till I see the sequence diagram. But do you see package variant for each? For SMF versus UPF versus AMF, that kind of thing.
Yeah, so those are different. So if they need
Different
customization,
packages.
yeah, they're
Type.
just different packages. So this is the underlying machinery that each package would get run through to do the fan out and to do the customization per cluster.
Yeah. And it would go into different local repo, right? For now. The
Yeah,
result of that.
the result of that would go into, so what Aravin's going to show is actually using package variant twice. Once to kind of create the stream package.
Yep.
So we have two things where, and I'll give
Got it.
preview. So we had two back in the workshop. There were two things we injected. One was we injected information that was invariant across clusters. That was the M injector. And two, we injected information that varied across clusters, like cluster context. And three, we injected sort of information that needed to combine those things, and that's through the IPAM injection and stuff. So in this workflow, we move that injection of the invariant information before fan out by having the controller do it directly. It could either directly create a package revision and add that invariant information. I think right now, in his diagram, he's using a package variant to do that, just kind of for the convenience of it managing the future life cycle and stuff. And then we fan out, and then we do those injections. So we'll see the diagram.
Yeah, I was stuck on that last night for SMF. I was like, do I do it shift left or shift right? But then I came to the conclusion that it's really two phases. The invariant stuff and then the local workload specific stuff.
Yes, exactly.
Not very scientific terms. Sorry.
No. And then there's really okay. Go ahead.
Yeah, no, I'll wait till, maybe it's better to wait till it's done. So it's just to waste no time. I'll wait till the end. Yeah.
Okay. I'll also wait till the end then. Yeah. Thanks.
Yeah.
All right. Take over.
Okay, sounds good. Just give me a second. Okay, can you guys see the diagram here? Can you guys see my screen?
Yes, we can.
Okay, perfect. So I'm going to zoom out a little bit and then we can zoom in, right? I just want to make sure I kind of broadly introduce the different things here, right? Is this visible when I zoom out all the headers or no?
You have to read out.
Yeah, I know I'm going to read out. Okay. So, so I've used, instead of using specific names, network designer or whatever, I've just said person A, person B to reduce contention. So person A is the one who's going to initiate this whole workflow for us, right? And the person A has the privilege of proposing a package, if you will, in the proposal approval workflow, but he or she doesn't have the permission to per se approve the package, because in the Porsche workflow, right, there is this draft state, and then that's when you are initially creating the package, someone reviews it and they propose that package, and after it's proposed, someone else probably reviews it and approves the package, right? So here what I'm saying is person A can create a draft package and basically propose the package, and person B here is the approver of the package, right, on the far right. We will go into the detail, but I just want to broadly introduce first. And then as far as the different controllers are concerned, we have the NF topology controller, whatever we had in the one summit. But the role of NF topology controller has changed a bit in this flow, right? And then there is a package variant controller, which deals with package variants, that the primitive that John kind of introduced, right? And the other one is package variance set controller, which deals with package variance sets. And then we have the IPAM controller, similar to what we had in the One Summit repo. On the far right, I've shown two things. One is config sync that runs on the workload cluster 1. So I'm using, so that the setup here is there is one management cluster, which is trying to manage two workload clusters, right? That's the setup for which we are showing the workflow here. On the far right, like I said, there is config sync on workload cluster 1, which is installed, and config sync on workload cluster 2 that is installed. So one thing I want to do is I wanted to show this in the diagram, but I ran out of time, is before any of these workflow starts, we need to understand what is already available in the workload, in the management cluster and the workload cluster, right? Like we need to understand what is the setup, right? In principle, like before we start this workflow, the workload cluster 1 Git repository and the workload cluster 2 Git repository should have been already registered with management cluster, like we discussed in the first half of the discussion, right? Once you do that registration, the CRs we spoke about, repository custom resource that we spoke about in the first half of the discussion, the one repository custom resource will be created for workload cluster 1, and a different one will be created for workload cluster 2. So these are details that we don't really have to worry about. Porsche handles it, but it's good to know, right? And then also you should have installed config sync on each workload cluster and point them to these different Git repos, right? So config sync on workload cluster 1 should point to its Git repo, and config sync on workload cluster 2 should point to workload cluster 2 repo, right? And of course, you have to install all the controllers in the management cluster. So after all this is set up, then we are talking about this flow. Okay, so that's the step 0, if you will, before any of this happens. So now with that background, let's maybe jump into it a little bit. I'm going to zoom.
So Arvind, just missed the point. So you're saying that from the management cluster perspective, we need to register all the Git repos and also the workload clusters, right?
Right. From the management cluster
This
perspective,
management cluster needs to know all the repos as well, right?
Yes, it needs to know, because it is going to, like, as part of the workflow, right? Let's say if it wants to push a package to workload cluster 1 repo, right? Then it has to push a repo to that, push package to that repo, which is then synced by config sync downstream, right? So it needs to have access. Yes.
Yeah. Thanks.
Yeah, before I start, I'll also clarify this, right? Like, the other set of repos, workload clusters each have a repo, right? Besides that, we are going to talk about two repositories. One is the blueprint repository, or the catalog repository, however you want to call it, which contains different blueprints, templates, if you will, for different types of NFs, right? In our case, we are going to take UPF as the example and kind of walk through it, right? So there is a blueprint repository, and there is one other repository which we are going to refer to is the organization repository, or you can think of a repository where you can modify packages before you actually push it to workload cluster. So this is an intermediate repository. So you have a template repository where you don't want to do any modification because different people will source from it, right? Blueprint is common and everybody customizes it. So this organization repository is where you take that blueprint repository, a package from the blueprint repository, and you kind of customize it. Right. So when I say organization repository, think of it as a repository where you clone a package and kind of play with it. John, please go ahead.
Yeah. Just to say, that's exactly right. But as I sort of said before, like that's kind of arbitrary and could be different in different FEO deployments. Mental model wise, the thought is an external vendor publishes a package in your organization. You bring that package in. You add customizations for your organization, your individual policies that apply organization-wide, et cetera. Maybe they clone that. Maybe then an application team clones that and adds their application team specifics. And then that serves as still the base for deploying many different instances of that you know, so that's kind of it's just a hierarchy for how we can further refine a customization and utilize those dry or one-time made customizations. But effectively from a technical point of view, an upstream is an upstream is an upstream, whether it came from an external, an organizational, or a team. That's all kind of arbitrary.
Right, exactly. Yep. I see a hand raised. Sundar?
Yeah, a quick question. So could we have a set of package variants that compose together for a given deployment? Like what I mean is was one upstream repo, but several downstream repos. So you got organization, maybe departments within it and so on, forming a chain.
Yes, we can. Sorry, go ahead, John. If you want.
Yeah, so you can, but right now so there's two different ways to compose a composition. One is to take multiple packages, put them into one package, and then deploy that as a unit. That works, but it's really complicated, and there's issues with it in various ways. The other type of composition, which I think is what you're saying, is I wouldn't say it's composition. I would say it's reuse, which is take the same upstream and use it in many different downstreams. And that's when we do that automatically, we call that fan out, and that's what package variant and package variant set manage for you, the automation of that. But you can absolutely do that manually and do that as many times as you want and customize it in any way you want.
Well, I'm thinking of a scenario where got a chain of these things. So one upstream repo, but an organization took it and they made some changes. One department within that made further changes before deploying it further. So it could be two or more such package variants in the sequence, right?
Yes, absolutely. Yep. You can have a whole chain as long as you need it to be. And this is one of the cool things, is that when somebody at the root of that or anywhere in that sequence creates a new version number, we can automatically discover all the packages in the hierarchy below it that would need update. And the owners of those individual packages can take those updates on the timeline they see fit.
Great. On a related note, I think I mentioned things like KPT functions to apply policies and make customizations, right? How would they fit into this package variant model?
This is an excellent question. So first of all, package variant and package variant set are partially developed. They're coming out of, I mean, there's other use cases for them, but the driver for them right now is this project. So we have a lot of say over what gets in there. My current thinking, so every kept package has a pipeline of functions that get run every time you save the package with Porch, or if you're using the CLI, you do run it yourself. But the idea is that those should all be idempotent. You should be able to run it over and over and over again. So the question is, should package variant as a resource be able to add to that list? Should package variant as a resource have its own list that it manages that's separate from that list? It's actually an open question. So I would, I'll put in the chat in a moment, or in the agenda better even, a link to my design proposal for package variant, some of which is implemented, some of which is not. And that's literally an open question right now, is what you just asked.
Okay, thank you. Good, that clarifies, yeah.
Sure. Rob.
Okay.
Sorry.
A couple of comments. So I think Wim, or maybe we have another working document that describes the role. So I would suggest to kind of replace the person A with that specific role. So then it becomes consistent with the other documents. So I think there's person A, person B, and all being mentioned this workflow. Does that make sense?
I'm happy to change that. Like if the roles are, I did look at the doc. If the roles are finalized, I'll maybe sync with Wim and make sure it's finalized, because I didn't want to open that up for debate. I just wanted to show the capability, and then we can replace this, whatever role we think is relevant. I'm happy to change it.
We'll have to line it up. But I think what is good is already to see the concept here. So what we have to do is line up all the CRD discussion and everything.
Yes.
That you have one document which is consistent at the moment. But we are doing a bit divide and conquer in order to make a bit of progress and get information out in order to get more information. But you are 100% correct. We have to line this up. Good point.
Yeah. The other thing I had question was, right, I mean, when we talk, I think there was this mention about a package variant controller too. So I'm assuming that when this network topology controller sees, okay, there's a new CR of network topology service, then that kind of invoking that package variant controller to generate this package variant CR? Is that how internally something?
The package variant CR is what invokes the package variant controller. So that's how you utilize the package variant controllers, by creating that resource. And then that
okay, got it.
The package variant, like stepping back from that sequence diagram, package variant controller, its input is the package variant resource, which contains a reference to a package. Its output is it instantiates a package to effectively, from a Kubernetes perspective, its output is a package revision. resource.
Okay.
So that package revision resource then can be watched by our injectors and our other fancy things that we do later.
Okay, sure. Other just a side comment. I mean, probably BP may not be very clear to everybody, but you can probably spell it out as blueprint. I was trying to figure out what BP means, then I realized. Okay, just another comment.
Yeah, we can update that. Yep. Sorry, in the interest of time, should we proceed a little bit? Maybe some of the questions will get answered. I'm okay to take questions, but we will run out of time. What do you guys think? Is that okay, Bala? Like,
Sure. Yeah, that's fine.
I think it's maybe better to go to the end, and I finish it, and then we'll do questions at the end.
Yeah, exactly. I mean, because I think some of the questions might get answered, and then maybe, yeah. Let's go ahead.
Aravind, we lost your voice, I think.
Oh, I'm sorry. Yeah, can you hear me?
Yeah.
Yeah, sorry.
Mhm.
Thank you. Person A applies enough topology to the management cluster. That's where the workflow starts. At that point, enough topology controller kind of tries to reconcile that CR. And what it does is it creates a package variant. I think there was a question earlier. The interface between enough topology controller and package variant controller is kind of this package variant API, if you will, right? Like, so enough topology controller creates the package variant. And here, I've showed there's some typo here, but the point here is there is an upstream repo and the downstream repo. And the upstream repo is the UPF blueprint repository, like for lack of a better name. And the downstream repo is UPF organizational repository. And the package name here is UPF blueprint package. I've just made the name so that it's easy for us to kind of understand. So UPF blueprint modified package. This is the package we are going to take and modify, right? How we are going to modify, we are going to see. But the idea is blueprint repository, we don't touch that, right? It's like a template, it's fixed. We take it to a different repo and then modify and do whatever injections we need to do in that repository before we actually push it to the workload cluster, right? So once the package variant is created, then step 3 is the package variant controller is the one that reconciles package variant, right? As at this step, it kind of creates a couple of other resources, which was introduced in the first half of the discussion, is package revision and package revision resources. What I've shown here is only, I mean, we cannot possibly show everything here. The sequence diagram was getting super long, right? So I restricted myself to show only package revision resources because that's the one that all the controllers modify. We watch for the package revision, but we only modify the package revision resources. So as you can see, the package revision resources is containing the package name, which is UPF blueprint modified, like we showed in step 2. And the repository name is UPF org repository, right? And the resources is basically a list of all the contents of the KEP package. So if you go to that organization repository, Git repository, you will see the contents of that repository, right? And here it's basically the whole contents. So the KEP package, I've not shown that, but UPF deployment.yaml file, if you have other YAML files, it will just show everything. Basically, the entire contents of the KEP package is kind of contained within this resources set. So each node is a different file in the repository. So there is a KEP file, there is a UPF deployment.yaml file. If you had image config.yaml like we did in the one summit, so that will be one, right? And so on and so forth, right? So we'll see how this gets modified, right, in the next steps. So one major difference, I think John kind of alluded to in the first half of the discussion, is that in the one summit repo, right, enough topology was kind of looked at by two different controllers, right? Part of the job was done by the enough topology controller, and the cluster invariance from the enough topology was injected by the enough injector controller. So what we have did here is, hey, let's make sure that only one person kind of reconciles, if you will, enough topology, right? Instead of splitting it across, it's a little bit awkward, right? So what we are trying to do here is let's make sure enough topology is the one that kind of reads from enough topology controller is the one that kind of looks at enough topology instead of splitting it across. So after we have cloned the package, now we are in a position in step 3. What we have done so far, just to summarize, is clone the package from the blueprint repository to an organization repository. That's all we have done so far. Now comes the question of injecting the different things from NF topology, right? We have done nothing with NF topology so far, right? At step 4, what we are doing is we are injecting all the cluster invariants, which is to say that things that don't change for each cluster, right? For example, the capacity information, which is contained in the NF topology, we inject that. I'm just trying to tie this to the OneSummit repo, sorry, OneSummit demo that we did. So this work was done by NF injector controller in OneSummit, right? The capacity was injected into the package revision resource by NF injector, but here we are saying that NF topology is going to do it. And it makes sense to do it before fan out because it's cluster invariant, right? So we are doing it before fan out. We inject the capacity, and also we are adding some conditions which will be satisfied later by IPAM injector, right? Things like, we know that like for a UPF from NF topology that let's say it needs N3, N4, N6 interfaces. So we're just saying creating conditions which will be satisfied at a later point in time, right? I want to pause for a second. I just want to make sure if people have followed till step 4, because I just don't want to go through without making sure. So far things are clear. So all we have done so far is cloned a package from a blueprint repo to organization repo and injected cluster invariants. That's all we have did so far. Yeah, please go ahead, Wim.
Yeah, so the cluster itself, you did not inject so far, right? So only
Yeah, fan out did not happen yet. Yes, fan out is going to come in the next couple of steps. So all we have did is injected cluster invariant stuff.
So Arvind, fundamental question. I think I understand this, but just for my own benefit, everybody else's benefit. So let's say in the upstream controller, right? Repository, there are 5 packages. And then in the step 3 or step 2 above, we just actually cloned a single package. So we are not worried about anything else, any other packages in the upstream. I just want to make sure that so we can clone at that granularity using this controller, right? Just wanted to understand that.
So yeah, so I'll clarify. I'll mention what I think, but I'll also let John chime in if he wants to add more. So package variant, right? At that step, we are cloning the entire repository, right? So if
we're cloning an individual package. In fact, we're cloning an individual revision of an individual package.
Oh yeah, that's right. Yeah, we have mentioned the package.
Actually points to a tag. And
yes.
So it's like UPF v7, and that's what we're cloning. Now, if tomorrow you come in and you change this package variant resource to point to UPF/v8, then this process kicks in again and it goes and proposes updates to the things it's created downstream. Okay. So that's how we manage the day 2 pieces, but it's not the whole repo, it's just an individual package. So if we had 7 different network functions, we would have 7 different package variant resources, 1 for each of those packages in this case, and then they would fan out to be even more.
Okay, right. Got it. So basically internally it has to clone the entire repo, but from the package variants perspective, it will only from the downstream repo perspective, it's only create a package variant resource for that particular package for that particular version.
So that's a great point. This is an overloaded use of the word clone. So if this were just a Git clone, then it would have to take the whole repo. It's not a Git clone. This is a kept our package clone. That's a different operation. It's not done. What we do is we pull the resource and we pull just the pack. We underlying, yes, probably it has to clone the whole repo, but when we do the push, we're just pushing that package. We're not pushing the rest of the repo. Actually, even the kept package get is going to pull just the directory. Like we're basically adding a layer of functionality on top of Git. So when we're talking about clone here, we're talking about that layer of functionality on top of Git or OCI that's just looking at it. When you get to how config sync has to pull it, it doesn't actually have direct support for pulling individual packages. It has support for Git and it has support for OCI. It actually doesn't, it's not, it's a different product. It's a different project. And yes, they work together, but they're not, it's not like it understands kept packages natively. It doesn't actually. So it doesn't do just a pull a package. clones the whole
So
Git.
that brings up a good question. Just follow up to Bala's question, right? Like what I'm thinking is, let's say NF topology contains SMF and UPF, for example, right? So obviously we have to create two package variants, one for SMF, specifying the SMF package and revision upstream, and similarly for UPF, right? So the clone, the actual clone, the Git clone, that it has to happen only once, right? Because if you
Yes.
bring everything to the cluster, internally Porsche can manage that. So we do the actual Git clone only once, right?
That's correct. The Git clone, back on config sync, if you've got multiple packages within the same underlying Git repository, it'll just do the Git clone once. And
No,
then,
no,
but-
no. Sorry,
okay.
I'm talking about Porsche, not about config sync. In the Porsche world, in the management cluster, when I create multiple package variants for the same upstream repo, but different packages within the same upstream repo, the clone of the Git clone of the upstream repo is done only once, right?
It's
my
done.
Porsche.
It's actually done. It's a underlying. It's just a cache for Porch that's done locally on a local volume of the Porch server as a cache.
Okay.
And then there's a separate thread basically or Go routine that's maintaining that cache up to match upstream so that we don't read from Git every time we want to like serve up a resource.
Yeah, that's
So, but yes, that's just done once.
Okay.
And then there's a whole management aspect going on under the hood of the Porch API server.
Okay. So just one point. No, that makes sense, John. So basically, if NF topology contains different NFs, the point here is NF topology controller will look at the NF topology and create different package variants for different NFs. So you will have UPF, SMF BP package, SMF BP repository, and things like that, or could be the same repository. Yeah.
Yes.
And please go ahead.
Quick question. So it seemed like we're adding a layer of functionality / abstraction above Git to, and is that the responsibility of, or the intention of Porch?
Yes, that's what Porch does. Yes.
Okay.
Above Git or OCI or potentially
Yeah.
you can put it in a bucket if you want it, right? Like it could be anything,
Yeah.
but so it's create that layer of abstraction, present these things as Kubernetes resources, then we can use Kubernetes techniques to operate on them.
So if we keep that in mind, just simplify things, right? Because earlier I keep confused Git clone, like you said, clone is not Git clone, it's the layer above. Okay, got it. Thanks.
I think the way I would describe it, John, I don't know whether it's correct, but this I have repo and you have packages, right? Porch manages packages within a repo, basically, right? So when it's the package things that we clone, basically, but because Porch has a local cache, he has the granularity of packages within the repo, so he can do that, right?
Yeah.
And
So
it's opinionated, right? The packages have to be tagged in a certain way, and if they're not, they don't appear. So there could be stuff in the Git repo that Porch can't manage. Right.
And so in other words, because we do with Git, we have to have a repo, but actually Porch manages package within a repo at the end of the day. Yeah.
So
Sorry.
follow-up question, sorry. Porsche, like you said, it works with GitHub, GitLab, and OCI, is that right?
Yeah. There's a number of different Git providers it works with, and it also can work with OCI registries.
Okay.
But I think in the context of
And it has
OCI
a cache.
Yeah, it's a
Sorry.
local. Sorry, I was just trying to clarify. Also, for OCI, you don't have this concept of a repo, right? So in OCI, I think a package by itself is an individual OCI package.
Well,
Is
there's
that
a
correct?
registry that the repo I think corresponds to a registry, and then yeah.
Okay.
So let's not get into that because we're almost out of time and we still have a
Okay, yeah,
lot.
sorry. Let's stop. Yeah.
I don't think we'll have time to finish. Maybe we can go as far as we can and maybe continue in the next session. But just to summarize, we have cloned a repo. We have cloned a package, to be precise. We have cloned a package, injected all the cluster invariants so far, right? Now that we have injected the cluster invariants, we could fan out, right? That's the next step. And for that, NF topology controller, the next thing it will do is it will create something called as package variance set, which was introduced earlier, right? What this contains is two things. One is upstream. What is the package and the repo that you need to fan out from, right? As you can see here, we are fanning out from the the package called UPF blueprint modified, which is the one that we just injected, right? We injected all the cluster invariants to this package, UPF blueprint modified. And then the next thing we mention is like, what are the repositories, to which you need to fan this out to, right? That's the next thing. So I've just shown one example. There are many ways to do this, but let's not get into that. Like here, it's just a selector where we are saying that, hey, you know, find all the clusters that match these annotations and then fan it out to those. So previously, at the beginning of the talk, right, I mentioned that before any of these begin, you need to register multiple repositories with Porsche, right? Like the workload cluster 1 repository, the workload cluster 2 repository. So those repositories should have been annotated with these labels. John, anything you want to add here?
Nope, that's fine.
Okay, so we have two repositories, workload cluster 1 and 2. Like if those were annotated with these labels, then package variant set controller will be able to find it. So let's keep going, right? Like, so we created a package variant set, and all we have told it is, hey, take this upstream package and fan it out to all the repositories that match these labels, right? That's what we are instructing package variant set to do. Now going to the top, right? So this line here is package variant set controller. Now the package variant set controller kicks in, right? It's going to reconcile the package variant set that we just created in the previous step. What it does is now it creates package variant set creates package variant, right? So it creates two package variants, right? One for workload cluster 1 and one for workload cluster 2. So this is the fan out part, right? And after this, as we discussed previously, right? When a package variant is created, it is reconciled by the package variant controller, right? And package variant controller, what it does is basically clones the package and then creates that's the next step that we are going to show here. So corresponding to each of these package variants, the package variant controller, so this line here is package variant controller, that kicks in and creates, like we saw before, package revision and package revision resources, right? So 7A is for workload cluster 1, 7B is for workload cluster 2. So whatever package we just saw earlier, it's just replicated, right? The blueprint modified, except that the package is for workload cluster 1 and 2.
And who determines the name?
So the name, I think John can add. There is some nuances there. So John, do you want to add?
So what package variant set does, that resource, is it describes a list of targets. The targets are repo and package name. So it takes an upstream and some sort of targeting criteria and generates the upstream is a repo and a package reference. The downstreams that it puts in each package variant is a repo and a package name. And that package name might be the same for each different repo, or it might be different. I mean, those are independent. You could have you could actually fan out to a single repo with multiple different names if you wanted to, there's use cases for that. Or you could, in our use case, you fan out potentially the same package name to every single repo, but they're all to different repos. So that's
my earlier question that I had was the following: how or where is the cluster specific information? Where do you get that?
So that should be injected in 7A or like an 8A or something. I don't know if that's in the diagram because package variant doesn't actually do the injection yet, so it's not sufficient to meet our needs yet.
Join back in a second. Sorry.
But it should inject when it creates, when 7A and 7B happen, it should do an injection. So in addition to the targeting, so if you go, the link I put in talks about this, but in addition to the targeting, which you can change the package name, you should be able to do an injection, and we should be able to define a sort of selector for injection targets and do it, but it doesn't do it yet.
Right. Okay. Yeah. Because I think for the injectors they need to have that context.
Yes, they do. Absolutely. Yes. So we need to add that functionality.
Sorry. One thing.
Yeah.
I was moving across room, so I might have missed it. So one thing I want to clarify is, so the repositories are registered, right? So based on what repositories are registered and matched, that's where it gets the number of repositories to fan out to. I
Right,
don't know if there was
Wynn's
a question.
asking about, so in the workshop, we injected cluster context. That's actually a piece that has information that's unique to each of those fanned out packages, each of
Right.
those clusters, which is then used as part of the lookup information in the IPIM. So if you have a different subnet per
Right.
cluster,
Right.
you need to know which cluster you're
So-
provisioning an IP for.
So there are a couple of ways to do that. One is package variant controller could support that, which it does not today,
Right.
right? As part of the injection, or we could have a different controller come and satisfy that requirement if we need to.
We could, but the intent is for package variant to support that. That was always the intent, because it's supposed to replace package deployment controller. Those two
Right.
resources are supposed to, and they don't fully replace it yet, basically.
Exactly. Yeah. Yep. Okay. Yeah, we are out of time. So how do we want to handle this? Like, do we want to continue in the next session? We should not be rushing this.
Yeah, that's fine. I guess we can continue in that session. What I would ask, Arvind, is that you go into the agenda and you share all of these documents.
Yeah, I will.
And people can even review them on their own time and ask questions at a time, but we
Yeah.
can continue this next week.
Sounds good. Yep.
So,
do
so,
that.
so John, before we split, I just had a fundamental question. So in the did we
Yeah.
lose John? Oh, okay. Sorry, John. We in the workshop we had this concept of local config and annotations with
That's
are
still
we
here.
the same technique here?
Yes, yes,
Okay,
that's still
thank you.
here. Yeah. Is Ann still, did Ann drop? She had her hand up, but I guess she dropped off. Okay. Okay. All right. Thank you, everybody.
Yeah,
Okay,
great.
thanks.
Thanks very much. Bye-bye.
Bye.
Thank you, Arvind. Thank
Yeah.
you, John.
Thank